About 1,2 trillion eggs are produced worldwide. Eggs are a known source of protein for the immune system and muscle growth, and choline for the liver and for babies' brain development. Eggs are superfoods. Aside from the usual scrambles and omelets, eggs are used in soups, baked goods, pastas, meat dishes, and more. The most common egg for consumption comes from chickens, although eggs from ducks and quails are also consumed in different parts of the world. Let's take a look at the most popular egg choice, the chicken egg. Its basic shape is called a prolate spheroid, which means cylindrical with one end bigger than the other. The basic anatomy of an egg consists of 5 main components: the air cell, the eggshell, the membrane, the egg white, and the yolk. The air cell is found at the largest end of the egg. Air cells can help tell if eggs are fresh. Older eggs have bigger air cells due to air sucked through the pores of the egg over time. This is why rotten eggs float, because it has accumulated too much air inside its air cells. The eggshell is the hard protective cover of the egg made up of calcium carbonate. Its color doesn't necessarily indicate the egg's quality or nutritional value. Eggshell color varies because of the various pigments deposited during egg formation. Usually, if the hen's earlobes or feathers are white, white eggs will be produced. If these are red, they will lay brown eggs. The shell membrane keeps the yolk and white of the egg together and protects it from bacteria. These are strong and made partially of keratin, a type of protein also found in human hair. The egg white, or the albumin, which cushions the yolk, is composed of 10% protein and 90% water. As food, egg whites are useful as binders for baking. And because these are high in collagen, a protein that promotes skin elasticity, egg whites are also used to make face masks. And finally, the egg's yellowish center, the yolk. It makes up 31% of the entire egg weight and contains plenty of vitamins and minerals. The color of the yolk is dependent on the hen's diet. Eggs from pasture-raised hens are said to have more omega-3 and less cholesterol due to its consumption of natural feed.
It is a beautiful Tuesday afternoon, and they can only mean physical sciences. Welcome to the show. I am Tobile. I want to send a great and a big shout out to Liberty. Thank you so much once again for sponsoring the show. Thank you so much for giving us the opportunity to help the class of 2021. I know that the prelims have just started and you guys are right on the way. And grade 12s, I want to remind you, if you haven't done it yet, please do download the Tenfold education app. It is an app filled with tons and tons of past papers that can help you guys prepare, especially now for your prelims as well as the final at the end of the year. And if you're wondering what questions we're doing, I'd like to join in the fun, please do send a hi on the WhatsApp number on the screen, and we shall then be sending you the questions on my Wacom. And if you want another platform we were actually active and awake is on YouTube. Please do follow us on YouTube, and there we are Mindset Learn. So in today's show, we're doing revision, and we're doing all about electrostatics. This is actually another one of my favorite topics, especially in paper 1. It can get a little tricky, but it's not really that difficult. Something to remember, we use a lot of vector diagrams, and a positive and a negative just mean direction. And I'm going to show you guys the tricks and traits on how to answer the question. So we've got a few learner questions. Thank you so much for sending those learner questions. The first one is and this question was question 7. I don't know from which question paper it comes from, but we are told that a particle P, and it already has a charge of, it's a positive 5 times 10 to the negative 6. I just want to show you here, you have to make sure that your charge is already in Coulomb. If it's not, if they've given it to you in nano, micro, and so forth, you have to convert it. Unfortunately, it's not on the formula sheet, so it's something that you need to know off by heart. So, and it's located 1 meter along a straight line from particle V. So these are the two in question. And V has a charge of positive, so it's another positive, 7 times 10 to the negative 6 Coulomb, and this is the diagram that we are looking at. So let's just see. I can see that P is a positive, V is a positive, which means that there's a force of repulsion. Remember what we learned in grade 10, like charges will repel and unlike charges will attract. So in this case, a positive and a positive are going to really see a force of repulsion. And then we've got Q. Nothing has been said by Q yet, but now we know when we're doing electrostatics, distance is very important. The distance between P and V is 1 meter. The distance between P and Q is X, which means that the distance between Q and V needs to be this 1 meter minus the X, because these two, X plus this one, should then give us 1. So subtracting these two should give me this one. So already in your mind, you need to see that somewhere, somehow, they might ask you the distance of X. Now you have to see between the two, think like a scientist, and then that's how I got 1 minus X. We've continued to be told that a third charge, which is Q, at point X meters away from P, as shown in the diagram above, experiences a net, remember the word net just means total, the net electrostatic force of 0. So this means whatever Q is, when it is forced with Q, with V, let's say hypothetically speaking, it's attracting, it's also attracting on this side. The minute it means it's 0, I just want to use values, 4 and 4. 4 minus 4 will give you 0. This means that these charges must be the same, but then in opposite direction. Remember in physics, when we have vectors in opposite direction, vectors have magnitude and direction. In opposite directions, we have to subtract. This means if the net force is 0, they must be equal, but in the opposite direction. That's the only way I'm going to get a 0. So right in your mind, you must start thinking like that. So let's see what my first question has. Number 7.1 says, how do the electrostatic forces experienced by Q due to the charge on P and V, respectively, compare with each other? That's exactly what we're talking about. So we can therefore say that the two forces must be equal. Remember the 4 plus 4, the 4 and 4. However, you can say but. Let's say equal in magnitude. Let's just use correct terminology. Let's say equal in magnitude. Remember, magnitude just means size. Magnitude. So they must be equal in magnitude. But, or however, they must be in opposite direction. But they are in opposite directions. They're in opposite directions. So you're already showing the examiner that you understand a lot about vectors and what it means when something is a zero and so forth. So for P to experience a net electrostatic force of 0, it means that the vectors are in opposite directions, but they must be equal in size. That's the only way we can get 0. Anything along those lines, the examiner will give you a mark. You'll get a mark for having in equal in size, or if they are same amount of the net electrostatic force, but in different directions. So anything along those lines. And then 7.2 says state Coulomb's law in words. So remember, definitions you must always know. So with Coulomb's law, it's a little bit long. It is the magnitude. Please stick to the correct terminology because you do get marks for actually having the correct words. Electrostatic. So the magnitude of the electrostatic force, which is exerted by 1 point charge. 1 point charge. Now remember, we identify point charges as Q1 by 1 point charge to another point charge and the second point charge we can call Q2. We know is directly proportional to the product of the charges and inversely proportional. To the square of the distance. And remember, distance we identify by R, by the distance between them. So it says the magnitude of the electrostatic force exerted by 1 point charge Q to another point charge Q2 is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. How I always teach my children, especially when it comes to definitions, most of the time your definitions or your laws and all that comes from the formula itself. If you actually read the statement, you're actually more likely to be able to plot the formula F is equal to K Q1 Q2 over R squared. And that's exactly what it's saying. And we know that F will then be directly proportional to the numerator and inversely proportional to the denominator, being the squared distance between them. But nonetheless, remember, always try to use your definitions along with the formula. That's how I did it in grade 12, and it really kind of made it easier for me. Let's look at the next question. So number 7 says I must calculate the distance x between them, and this is for 5 marks. Just want to go back here. So we have 2 things that are not known. I don't have the charge of Q. I also don't know the charge of X. So it's one of 2 things. I know that Q is experiencing a net electrostatic force between P and V. So now there's 2 ways in which you can do it. You can use the net electrostatic force or the net electric field. So what we can do is we can look at the force of attraction between P and Q as well as Q and V. Remember, vectors in opposite directions means we're going to subtract the 2. I'm going to do it in one way, and then I'm going to show you another way in which you could have done it. I tried it in the second way, and then I also got exactly the same answer. So just want to open enough space over here. So we need to find the distance R between them. So with my first step, remember, we use the formula F is equal to K, which is a constant, Q1, Q2, all over R squared. But this is how I'm going to do it. I'm going to say I'm looking for the force between P and Q. I'm going to have my K, Q1, Q2 all over R squared. I'm going to start with these 2. K is a constant, which is 9 times 10 to the exponent 9. The charge of P is given to me, which is 5 times 10 to the negative 6. I'm going to keep my Q there, even though it's going to be the same on the other side. The distance between P and Q, I was told, is x squared. Remember, distance is squared. And then I'm going to find the force between V and Q. K is a constant, Q1, Q2, all over distance squared. K is a constant, we should get on your formula sheet. But I think you guys have done this so much, my darlings, that you probably also know the formulas and the constants off by heart already. And I'm going to keep the Q there. And the distance between V and Q, remember we said will be 1 minus the X. So I'm going to keep it exactly like that in a bracket and remember to say squared. So that will give me 1 minus X and that will give me squared. So now I'm going to work on the top part. So I'm going to put it exactly as it is in my calculator so I can start working it down. I like putting brackets around all my stuff, especially if you're working with exponents. Otherwise, you don't want your calculator to do bod mass and try the exponents first. And that's to a negative 6. Close that bracket. So I get 45,000. So I'm going to get 4, 5, 1, 2, 3. You still have a Q over there, all over x squared. And on this side, I'm going to do exactly the same thing. So there's various methods you could have used in mathematics to do it. But now, I just took one method that just made logical sense to me. But always remember, don't just write the answer. As the examiners, we want to see your steps. Sometimes you might think that, oh, my steps are not quite right or my answer's not right. But as an examiner, we can see the procedure or the step you were trying to make. And you might never know. You might just discover a new way of actually figuring out a formula. Here I get 63,000. So I get 63123. I still have a Q. And this is all over 1 minus x squared. So now remember that we were told that Q is experiencing a net charge of 0. Vectors in opposite directions, we said we're going to subtract. So it doesn't matter, you have to just choose direction. You must just choose direction over there. So I just want to take it or do it the long way around so everyone knows what I'm doing. Remember now with F net for this one, it was the force of attraction between P and Q minus the force of V on Q. I'm told that F net is 0. With F of Q, this is what I got. I'm not going to solve it because that's still on a square root. So I'm going to have 45,000 and I'm going to have a Q all over x squared minus. I'm going to take this side exactly as it is, 63,000. I still have a Q there. Don't worry, the Q is going to cancel anytime soon. Just want to write this one properly. Bracket, and that's squared. So I'm going to have 1 minus x squared. Now, this is just mathematics. First of all, I'm going to take this side to the other side. I'm going to equate the two equations, which means I can cancel the q's. Moving this one to the other side means I can put both under square root to get rid of the exponents. So I'm going to take this side on this side. Remember, if any number jumps the equation sign, the sign will change. I have 45,000 on this side. Oh, my voice is leaving me. I've got x squared, and then I've put both under square root. The q's will cancel. Let me just put these under square root. Let's see what I get there. Oh, there it's back. 63123. I get 250. I'm going to leave my answer to 3 decimal places. So that is 998. So I get 250,998. I think, let me just catch my voice quickly. Let's go to an ad break, and when we get back, I'm going to continue with this problem.
No one ever asks why we do the weird things we do. Like, why once is never enough? Or doing 2 trips is just one too many? Why do we, before we use these? Or say 5, when we mean 120. Why do we have second thoughts? And think that lift buttons make them go faster? Why don't we walk there? Cross our fingers, touch wood, and struggle to hide our true feelings. At Liberty, we want to know all the weird and wonderful things that make us human, because human beings, being human, are what we make financial solutions for. Liberty, in it with you.
Did you know that humans only developed blonde hair about 11,000 years ago? Scientists believe that blonde hair developed in Northern Europe during the last ice age as an evolutionary adaptation arising from the necessity for vitamin D. In an area with less solar radiation, lighter skin and hair allows sunlight to more easily trigger the production of vitamin D. Blonde hair is still most common in Scandinavian countries.
And your girl is back with her voice. So let's continue with the question that we were doing. So I put both under square roots, cancelled both the q's because it is the same. When I put all of this under square root, the number I get 250,998. I'm going to leave my answer to three decimal places. Remember, only your final answer can be rounded off to 2. If I put all of this under square root, the exponent also then cancels, leaving me with this side by having 1 minus x equal. I'm going to do exactly the same thing on this side with the number. So I'm going to put the 45,000 under the square root, getting 212,132. So I'm going to get 212,132. Putting all of this under square root cancels my exponent, and that just leaves me with an x. So this is just more mathematics. Now we know if we have two fractions separated by an equation sign, I'm going to have to cross multiply. I'm just going to keep this in a bracket so that I can show you how we're going to cross multiply. This is going to be 1 minus x. I'm going to multiply this with that, this one with this one. So it's 212,132 is equal to 250,998 multiplied by x will give me 250,998x. Now this is just maths. I'm going to multiply that with 1, leaving me with 212,132. Multiplying this number multiplied by negative x gives me negative 212,132x, still equal to 250,998x. Now I'm going to move all my x values to one side so that I can solve, leaving me with 212,132 on this side. I'm going to have this. I don't want to take any shortcuts, just in case somebody gets confused. This number is going to come over the equation sign. It is a negative on this side, becomes a positive on this side. 212,132x. Let me just write the next step. Remember, it's only for 5 marks. You could have shortened it. I'm going to do it the long way around so that everyone knows exactly what I'm doing. Plus the 212,132. And then I get 463,13. So I get 463,13. And remember, that is an x. Let me just see if was there any other number after that. It was just that. So now I need to get x by itself. What am I going to do? I'm going to divide both sides with the number that is bothering the x. In this case being 463,13. What you do on this side, you do on the other side. So this and this will cancel, leaving me with an x. So let's see what the distance is. So just have it under an exponent, 212,132, all divided by 463,13. And then I get 0,46. Remember, to 2 decimal places, if the third number is 5 or greater, changes the number in front of it to its next value. And that's how I get 0.46. Now remember, we were looking for distance, so the SI unit is then in meters. So the important thing with using this one was just to remember that it's vectors in opposite directions. I do want to show you this though. If you decided to use, so I just want to write an or here. If you decided to use the electric field, remember that Q is experiencing a net charge. So you could have used the electric field as well. Same thing. Remember with the E net, we could have said, remember, we could have found K is a constant, the charge of P all over R squared minus K being and then the charge of V all over R squared. And we could have done the same thing. E net was 0. I won't do the whole thing. I just want to show you how you would have plugged it in. This would be 9. This one would have been, this is our constant, which is 9 times 10 to the 9. And P was 5 times 10 to the minus 6. I just want to show you something here. And then you would have still got a distance of X. Same thing on this side, 9 times 10 to the 9, where V was 7 times 10 to the minus 6. And the distance with V was 1 minus X squared. So as you can see, even though I'm using the electric field one, Q is not present here, whereas in this one, we cancel the Q here, leaving with exactly the same stuff. Just want to show you quickly. If you said 9 times that, you get the same step on this side, so it's exactly the same procedure. So you could have used the electrostatic force, or you could have used the electric field. But only to remember that Q experiences a net charge of 0, so vectors in opposite directions, you just had to subtract. And that is then how I would have answered this question. This question was actually a dual question. There was another one with one question that had question number 8. And with this one, it says a small metal sphere, which is called Y, carries a charge of a positive charge of 6 times 10 to the negative 6 coulombs. I already see that is actually nicely converted for me. So then 8.2 says, if 8 times 10 to the 13 electrons are now transferred to the sphere, so now they added on that sphere, calculate the electric field at a point 0.5 from the sphere. So here we have our Y, and it is a distance of 0.5 meters away, and we have a certain point there. So that's what we need to calculate. I do have the charge and I do have the number of electrons, but they want me to find the electric field. Now already I know that electric field is E is equal to K. This will be the charge of Y over the distance squared. K is a constant. Charge, I don't really have the charge. I have the charge before the electrons were added. So I must first find out what is the new charge once the 8 times 10 to the exponent 13 electrons are added. So can you see where I'm going? I do have the distance, so I just need to figure out that charge. So step number 1, in grade 10, we learned when two spheres rub together and move apart, electrons can be transferred or accepted, all right? So this is what we're doing. In grade 10, we learned how to calculate the number of electrons on a sphere and so forth. So we're going back to grade 10. So how do I need to do this one with the number of electrons that are there? I'm going to use the formula N, which is the number of electrons, the charge of an object, and then the charge of one electron. Remember, I'm looking for the charge. I want the charge of Y. So I just made Q the subject of the formula. So this is what you end up with. Number of electrons is what you were given, which is 8 times 10 to the 13. The charge of one electron you'll find on your formula sheet, which is negative 1,6 times 10 to the negative 19. Remember, if I was looking for the number, doesn't really matter whether it's a negative or positive. However, if I want to show that I'm adding electrons, it means that it changes the entire charge completely. So I need to use the negative. So let's put that in a calculator and see what we get there. Remember to put brackets around everything exactly as it is. That's 8 times 10 to the exponent 13. All multiplied by negative 1.6 times 10 to the exponent negative 19. And therefore I get, so I'm just going to move my comma 1, 2, 3, 4, 5. Let's say 6, so I keep it in 6. So remember, it is a negative. I moved my comma 6 times to 12,8 times 10 to the negative 6. Just write that 10 properly. Now remember, if you do wish to use to write it in that long form as a decimal and so forth, you're perfectly fine to do that. Only remember, you can only round off your final answer to 2 decimal places. So this means you have to keep writing that number over and over and over again so that you actually get the correct answer. Because if you keep rounding off your answer, then it doesn't really work out as well. So now that I've got the charge, let's see what happened. So now this is the charge that I got. But I'm looking for the net charge. Remember, Y had an original charge of 6. Then they added the electrons. This is the charge that it had, which is now the net charge that I need to look for. So my net charge, I'm going to take my initial charge, which was a positive, which was 6 times 10 to the negative 6. I need to add this charge, which is negative 12,8. Remember, electrons were added, which is times 10 to the negative 6. So let's see what I get there. It is for 7 marks, so it was quite a bit of a stretch. But you just had to remember that you just needed to add the 2. So we have 6 times 10 to the exponent negative 6. That is the original charge. I need to add a charge of negative 12.8 multiplied by 10 to the exponent minus 6. Let's see the charge that we get there. There we are. So I'm just going to move my comma again. 1, 2, 3, 4, 5, 6. So it's going to be negative 6.8 times 10 to the negative 6. Negative 6,8 times 10 to the negative 6. And charge is measured in Coulomb, capital C. Small c is concentration. So, but we need to find the electric field. So this is the charge that I have once these amount of electrons were added to it. So what I technically did, I just found 8 times 10 to the 13 electrons. What is that charge? And then added to the original charge of the 6 times 10 to the negative 6. Electric field is this formula. Just want to write my formula again. Remember, you do get a mark for the correct formulas used. This is r squared. K is a constant, which is 9 times 10 to the exponent 9. We have a charge of 6,8 times 10 to the negative 6. Remember now, don't really need to put the negative because I'm just looking for the electric field. I was told that it's 0,5 meters away, and that is then squared. So I'm just going to put everything or plug in everything exactly as it is in my calculator. Always remember to put brackets over everything. I also advise you to put everything once. Otherwise, you have to keep rounding off and writing the number over and over. And then you just might kind of sort of make a mistake somewhere. So I get 6.8 times 10 to the exponent negative 6. Bring that down. This will all be 0,5 squared. And there we are. Let me see. Let me move my comma. 1, 2, 3, 4, 5. So you can move it 5 times. I'm going to say 2,45. Remember, it was a positive, and moving in the positive direction gives me times 10 to the 5. The electric field SI unit is in C minus 1, and it's towards the sphere. Towards the sphere. Okay, and this is then the last question that we actually have for this one here, and that was then for 7 marks. Okay, I am told we can actually go for another ad break. So I'll see you on the flip side.
Want to catch up on some of your studies? Join Mindset for late night studies. Monday is mathematics, Tuesday is physical sciences, with life sciences on Wednesday and accounting on Thursday. Friday is English, maths literacy on Saturday, and Sunday is a good day to catch up on geography. Every day from 9 p.m. till midnight, and again from midnight till 6 a.m. Late night studies, only on Mindset.
Did you know that humans only developed blonde hair about 11,000 years ago? Scientists believe that blonde hair developed in northern Europe during the last ice age as an evolutionary adaptation arising from the necessity for vitamin D. In an area with less solar radiation, lighter skin and hair allows sunlight to more easily trigger the production of vitamin D. Blonde hair is still most common in Scandinavian countries.
You are still tuned in to Tenfold Live. Welcome back to the show. Thank you so much for still staying tuned in with us. I am Tobile. I want to send a big shout out once again to Liberty. Thank you so much for sponsoring the show and for giving us this opportunity as well as this platform to help the class of 2021. And grade 12s, if you haven't done it yet, please do download the Tenfold Education app. I cannot stress it enough. It is an app filled with tons and tons of past papers that can help you prepare for your final examinations. I know the prelims have started and you can get all the help that you actually need. And if you're wondering what questions we're doing and you'd like to join in the fun, please do send a hi to the WhatsApp number on the screen. We shall then be sending you the questions that we're doing. Also, if you're finding that you want another platform where we're actually very active, is then on YouTube. Please do follow us on YouTube, and there we are then Mindset Learn. So right before the ad break, we were doing electrostatics, one of my favorite topics. We continue with electrostatics. Now we've got another question from a learner. It is Eno TF. It's also question 7. And Eno says, please help. So I'm going to once again show you how you answer it, the nitty-gritties, and how to go about it. Remember, electrostatics is a lot of vectors, so you need to understand that vectors in opposite directions, we need to subtract. You don't really use the negatives like how we used to in grade 10. Negatives just mean vectors. That's what you need to keep in mind. So with this question from Eno, which is also question 7, he says 2 small spheres, which are named X and Y, carry charges of positive 6 times 10 to the negative 6 coulomb, as well as positive 8 times 10 to the negative 6 coulomb. So already I can see we've got a positive and a positive, which means there's going to be a force of repulsion. Remember, like charges will repel, but unlike charges will then attract. I can also see that they placed 0.2 meters apart in the air. Hypothetically speaking, guys, if this was in centimeters, you have to convert it to meters. Remember, when we talk about distance in physical sciences, it has to be in meters, right? That is the correct SI unit that we actually use. So nonetheless, this is the diagram that we are given. Like many other questions, 7.1 says state Coulomb's law in words. We've already stated it in the previous one, so I just wrote it quickly during the ad break. So let's just read it. Stating Coulomb's law in words. Coulomb's law is the magnitude of the electrostatic force exerted by one point charge, which we call Q1, to another point charge Q2 is directly proportional to the product of the charges and inversely proportional to the square of the distance r between them. Not a lot of marks, 2 marks, but also what I always like telling my kids, you cannot fail definitions because you're lazy to read. So remember, read them as much as possible. Also write them over and over as much as possible. Or my little secret, always use a formula. If you actually read it through, you actually will be able to plot the formula. It actually works with most of them. So let's look at 7.2, but I see there's some information first. So now we are told that a third sphere, which is called Z, of unknown negative charge is now placed at a distance of 0.3 meters below sphere Y in such a way that the line joining the charged spheres of X and Y is perpendicular to the line joining the charged sphere Y and Z. Now, you already can see this is going to be in 2 dimensions as shown in the diagram below. So this is my diagram. So I can see that, okay, I have a force of between X and I've got a force of Y, and then I've got a force of Y and Z. If I look at X and Y, it's going to be left to right, but when I look at Y and Z, it's going to be up and down. already I can see two-dimension. In grade 10, we taught you how to do head-to-tail methods or tail-to-head methods and so forth. So this is one of those scenarios. So let's see what we're told. Well, another thing I can see from this unknown diagram here is that Z does not actually have a charge. So let's see what we're told here. So we are told that we must draw a vector diagram showing the directions of the electrostatic forces and the net forces experienced by charged sphere Y due to the presence of charged sphere X and Z respectively. So I must draw a vector diagram with what is happening. So remember, when you draw a vector diagram, vector has got magnitude and direction. In physics, when we are indicating or showing that something is a vector, you have to use an arrow. It doesn't help you just have a line. You must show an arrow. So now they're saying with respect to Z, with respect to Y. So let's see. If I start off at Y, remember Y is a positive. This is how I show my class. So you can actually see my other finger. If C decided to move towards Y, remember, like charges will repel. Y won't go towards it because then that's a force of attraction. But Y will go, no, and it will move in the opposite direction. I go back to Y. And then X is now, it is an unknown charge, but I think we're told that it is a negative charge, which is X. And then when Z comes towards Y will want to then attract towards it. So I've got a force going to the right, I've got a force going down, which means that my F net will then be in the middle. So that's how I then get it. What I always tell my kids, they will tell you, or the question will speculate which one is in question. Always put your finger there. If this one's positive and I've got another positive, positives will run away, then it moves in the opposite direction. You go back to the one in question. In this case, it's Y. If Z comes along and it's opposite, Y says yes, 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 opposite charges, and then it moves towards it. And that is your vector diagram. But obviously, we have to make it look nice and not just like this. And always use a ruler. I cannot stress that enough. Your English teachers say you guys use a WhatsApp language, and other teachers say you don't use a ruler. So let's always try to use a ruler. And you can have F net moving in this direction. F net will be moving in this direction. This is the force of X on Y, and this is the force of Z on Y. That is then your vector diagram. You can actually close if you want it. Remember, if you do close it, it must just make a right angle triangle. The arrows shouldn't move. So let's see how this one would look. If I move this one that side, this one is coming down. This is then our head to tail method, which we've actually learned in grade 10. As you can see, Fz on Y, Fz on X. Let me just change this one quickly. X on Y is still moving in that direction, moving down, and also moving down here is Fyz. F net is still moving in that direction, still moving in this direction, will then be your F net. Also always remember to number or label your forces because it is for 3 marks. Number 7.4 says the magnitude of the net just means total, of the net electrostatic force experienced by charge Y is 15,20 newtons. Now this means I must calculate the charge on sphere Z. This is for 4 marks. So I want us to actually go back. So what are we missing? We don't know the value or the force of attraction between X and Y. That's something I can get. And then I also don't know the force of Y and Z, but I do know whatever it is, Y will experience a net charge of 15,20 newtons. I just want to go back to my diagram here. Dun, 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 dun. This is mathematics. Remember, if we have a right-angled triangle, this means we can actually move over to using theorem of Pythagoras, right? And then we are able to then find the force of Y. I can just see that there is a question missing here. There is no 7.2, so which means it might have been having to calculate this force here between X and Y. So we're going to start calculating that first, and then we're going to start plugging in all our other information. So let's find that force. Remember, we have a force. Let me just draw this again so that as I'm working with it, you'll know exactly what I'm talking about. So I'm going to find this one here. Remember, we had Y as well as we had, mine is actually the other way around. Here we had y, and here we have x, and then we have z moving down. So I'm going to start with this force here. I'm going to say F is equal to K, which is a constant, Q1, Q2, all over R squared. You can name it X and Y if it's going to make it easier for you. Remember that K is a constant, which will be 9 times 10 to the negative 9. I was given the values of X and Y, which is 6 times 10 to the negative 6, as well as 8 times 10 to the negative 6. I was told that the distance between them was 0.2 meters, so nothing had to be converted. Let me just plug that into my calculator exactly as it is. Just move it like this. Remember to put brackets over everything. 9 times 10 to the exponent 9. And 6 times 10 to the exponent negative 6. And 8 times 10 to the exponent negative 6. And that is all over 0.2, and that is squared. And therefore I get 10,8 newtons. So this is 10,8 newtons. Just want to go back to my free body diagram. So F and Y, I've got 10,8 newtons. That's the force there. Now I know that Y is experiencing a net force of 15,2. So this is what I can therefore do now. Because I need to find the charge on Y. I can therefore say F net. Let me just use a different color so that you can see where I'm coming from. I can say F net squared is equal, remember this is my horizontal and my vertical. This is going to be F of x y squared, remember theorem of Pythagoras, plus F of z y squared. Where am I getting this? I'm getting that from my diagram over here. This will be my y value. This will be my y, and then this will be my x. And then F net is acting as my hypotenuse. Remember, they told me that y is experiencing an F net force of 15,20. And that is squared is equal to, I just calculated F of y, which I got 10,8. Even if you got this answer wrong and you're not sure, please just plug it into the correct place. Because as long as you show the examiner that you actually knew that this answer over here was supposed to get there, that's more than enough. Now I'm just going to do mathematics. I'm going to take this to the other side. So I'm going to have 15,20, and that is squared minus. Remember, it's a positive on this side. If it jumps the equation sign, it becomes a negative. And I get 10,8 squared is equal to FZY. Let me just write it like this. I'm going to work that out in my calculator. I'm putting it exactly as it is. So I get 15,20, and that is squared. And my answer that I've got now, which was 10,8 squared. And therefore I get 114,4. Just want to write that down. Remember this is squared. I get 114,4. So I must put both under square root, and then I'm going to find the force between the two. So here I got 114,4. So I get a force of 1069. Remember, we're still looking for the charge on Z. So I'll leave my answer to like 3 decimal places. So I'll leave it to like 695. So I get a force of 10,695 newtons. But that's not what the question said. The question wanted the charge on Z. Now I'm going to go back to my original question, my original formula, which is now F, K, Q of Y, and Q of Z all over R squared. The force that I just calculated now, I do know that the force of attraction between Z and Y or the force rather, between Z and Y is at 1069. So I put that exactly as it is in my calculator or on my formula, 10,695. K is a constant, which is 9 times 10 to the exponent 9. Y, I did have a value for, which was 8 times 10 to the negative 6. I am looking for the charge of Z, which is just Z. The distance between the two I was given Let's just double check the distance here, which was 0.3 meters. And remember that is squared, 0.3 squared. Now, this is just mathematics. So once again, I like putting everything once in a calculator, so I'm going to do it the long way around. Hopefully everybody knows, who's going to see what I'm doing. I'm going to cross multiply. So this side I'm going to have 9 times 10 to the exponent 9 and 8 times 10 to the negative 6 with an x equal, I'm going to cross multiply these two, leaving me with 10,695 multiplied by 0.3 squared. But I want z by itself. I divide both sides with what is bothering my z, which is the 9 times 10 to the 9. So you can choose to actually work out your answer, get a very long number and write it down. I like avoiding that, and I don't teach my class that, because you tend to make silly mistakes if you're going to have to keep rounding off the entire time. So for me, it's just better to write down everything in the calculator exactly as it is. Then you know it's one shot and you're less likely to make mistakes, and no number is actually changed based on what we were given. So I've got 10,695 multiplied by 0.3 squared all over. I've got 9 times 10 to the exponent 9, and that is all multiplied with 8 times 10 to the exponent minus 6. There we are. So I'm going to move my comma, 1, 2, 3, 4, 5. So that's 1,34 times 10 to the negative 5. So that's 1,34 times 10 to the exponent negative 5, and that is then in Coulomb. I just want to go back to this formula right here. With this one, your vector diagram needed to be right. We know if it's a right angled triangle, we can use theorem of Pythagoras. Remember, in maths, we say r squared is equal to y squared plus x squared. We already knew what our hypotenuse was. That is what the y was experiencing, the 15,20. And then what I had to do was actually find the one force. This is the one that we found here. So using my theorem of Pythagoras, I was then able to find the force of z and y, which was that. So this means this force here is the force here on my formula sheet. Then I can solve for an unknown. So most of the time they'd actually ask you to calculate it in the other way around. But with this one, we actually had to first do theorem of Pythagoras and then work up, where in most cases it's just the other way around. It was a little bit tricky, I do get that, but not too bad. I just think the tricky part with electrostatics is the mathematics. So make sure that you take your time when you're doing the mathematics. I'll rather let you do it the long way around than to do chop and change over here and then you make silly mistakes. Remember, if the examiner's marking, it needs to make perfect sense. As well as you also need to get your answer. You also can't have an answer that is very wide away from the answer. For example, here we got, like in this question here, we got 1,34 times 10 to the negative 5. You also don't want to get 2,34 times 10 to the negative 5. But if you get 1,32 or something, it might be some rounding off somewhere here and there. But if you get 2, it means that there's quite a few things that might be wrong, and we're trying to avoid that. Okay, let's go to another question. This is another question. So this question here is by Zakes Baiki. I think I'm saying that right. And his question was then question number 5. And his question says, a small graphite-coated sphere, which is P, is rubbed. Now we know if things are rubbed, then charges are taking place. Is rubbed with a cloth. It is found that the sphere acquires a charge of 0.5. I must convert that to Coulomb. Now remember, if you have to convert that to Coulomb, this is what you learn in grade 10, you replace that by 10 to the negative 6, and then we lose the mute, and then it becomes then a C. So let's see what diagram we have here. So this means technically it was the original charge, they rubbed it. Now that it was rubbed, it's now moving towards, so there's a certain force of attraction that is actually then going on somewhere here. Another thing that I'm picking up, I can see that the distance is not the correct SI unit. Now remember, my distance must be in meters, so I divide that by 100 to move it to meters, so I get 0.2 meters. And then I can see that I also have R, not given much information about R yet, so let's see how it plays along. Now we've got 5.1. 5.1 says I must calculate the number of electrons. Number of electrons, dun, 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 is grade 10, removed from the sphere during the charging process. So let's see. We do have the charge. Once it was rubbed, now we need to find the number of electrons. Very, very easy. Remember, formula first. It's a small n. We have a Q all over the charge of an electron. The charge that the electron had after it was rubbed was 0.5 times 10 to the exponent negative 6. Now the charge of one electron is on your formula sheet. So luckily you don't have to know that off by heart, which is 1.6 times 10 to the negative 19. Now remember, I'm looking for the number of electrons. So I just want to divide the 1.6 times 10 to the negative 19 in the charge. I don't really have to use the negative because I'm not trying to find out the number of electrons that were removed or transferred or added. I just want the number of electrons. So the negative is not so important. So let's put that in our calculators. Let's see what we get. Exactly as it is. Remember to put brackets around your stuff. This will give me then 0.5 multiplied by 10 to the exponent negative 6. Remember the negative 6 we got because they just gave it to us in 0.5 and then the mini was not right. We had to then convert it. 1.6 times 10 to the exponent negative 19. Let's see what we get here. Dun, 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 dun. Let's see. The third number is greater than, it's 5 or greater. So it'll change the number in front of it to its next value. So this will give me 3.13. So this will be 3.13 times 10 to the 12. And what were we looking for? Electrons. We had to look for the number of electrons. So those were the electrons that we were looking at. Now it continues to say, now the charge sphere P is suspended from a light inextendable spring. So it just means they're just making it hang there with another sphere, which is R, with a charge of negative 0.9. Remember, I have to convert this to Coulomb by timesing it by 10. So this becomes 0.9 multiplied by 10 to the negative 6 on an insulated stand board closer. I just want to go back to my diagram here. This makes perfect sense why P is attracted to R. P is a positive, R is a negative 9 times 10 to the negative 6. And opposites will attract, and that's why P is moving towards the R. As a result, P moves to a position where it is 20 centimeters from R, which is, again, can't be in centimeters, it must be in meters, dividing that by 100. As shown, the system is in equilibrium. So now we can already see they're bringing in some Le Chatelier over here. So it is in equilibrium, and the angle between the string and the vertical is then 7 degrees. Number 5.2 says, draw a labeled free body diagram showing all the forces acting on sphere number P. So sphere number P is the one that is suspended on here. So let's see. I did see that it was for 3 marks. So let's see what can actually be working on this. Now we know if something is hanging somewhere, it must have some gravity. So it's Fg or some weight. I know that the positive is attracted to the R, which means there must be a force of attraction here, or an electrostatic force. Now I know the minute there's a string in something, with what we learned in Newton's laws, this means there must be some tension. 3 marks, 3 forces. I can see tension, Fg and Fe. Now remember, they said a labeled free body diagram. There is quite a different, guys. You don't have to redraw the structure and then add the arrows. Free body diagram just means that the point charge or the spheres are represented by a dot or a little circle, and then you have all your vectors. Also use a ruler and make sure that it actually is accurate. 3 marks means we have 3 forces. So we have P, that is my dot, which is representing P. My first force is my electrostatic force in that direction, because it is attracted to R. You don't have to write the R. We know that anything that is hanging has got the force of gravity. Why? Because if that string broke, then that sphere would fall. Also, I've got tension moving in this direction, which will then be a T. So that is my marks. Then 5.3. State Coulomb's law again in words. So the magnitude of the electrostatic force exerted by one point charge, which we call Q1, to another point charge Q2 is directly proportional to the product of the charge and inversely proportional to the square of the distance r between them. I hope you know this formula by now, guys, because we've been saying it and hopefully it's making a little bit more sense now. So now number 5.4 says calculate the magnitude of the tension in the string. Now once again, I want to go back to this diagram here. So you can use theorem of Pythagoras or vector diagrams once more to work it out. So I just want to draw here with another color. So for an example, remember when you draw a right angle triangle, the arrows or the vectors rather, they don't change direction. So the FG is still moving down, which we'll call FG. I know that tension will still move in that direction, which is represented as T. And then I know that my FE, which is my force, my electrostatic force, will move in that direction. I am told that this is then 7 degrees. So as you can see, this is exactly what I have. This is y, this is x, this represents your hypotenuse. Mathematics, you also use SOHCAHTOA and stuff, so you're more than welcome to use this one. So I'm going to show you how I would have calculated to find the tension using that string. So step number 1, if I look at my diagram over here, I need to find FE. Because I don't have FG, I was not given the mass. I can find FE. Why, or how do I know this? Because P and Q both have charges, so I can find the electrostatic force. Now, if I have one unknown actually, because I've got FE, I've also got an angle, I can therefore find my tension. Can therefore use tan. There's various options of using it, but from my head now I can just see tan. So let's first find FE. So if I find FE, it will be K, Q1, Q2 all over R squared. Remember, K is a constant, 9 times 10 to the 9. I was given both charges, which I already converted by putting times 10 to the negative 6. 0,9 times 10 to the negative 6. I was given the distance between them. 0,2. Remember to square that. Without wasting time, this is what I got. 0,10125 Newton. Remember, you only round off your final answer. But remember, I am looking for tension, so I'm going to use tan, because with tan I can use x and y. So I'm going to say tan 7, the degrees was 7. I'm going to say T of x over T of y. Remember, with x, I already had that. Tan 7 is my answer that I just calculated here, 0,10125. And then I can find T of y. Just going to cross multiply. Just going to put this over 1, cross multiply these two. And if you put everything in your calculator, you should then find 0,82 newtons. So the tension will then be 0,82 newtons. So this one was a little bit tricky, had a little bit more mathematics, but nonetheless, if you can draw the vector diagram and use opposite, adjacent, and hypotenuse, then you're more than likely to solve this one. Thank you so much for joining me this week one more time for electrostatics. All the best for your prelims, and I will see you next week.